Welcome to the next video in the GaneshaDx tutorial series. This time we're going to talk about our texture workflow. And I'm going to give you some tips on actually doing your textures. We're going to cover palettes and UV maps and all of that. I know that we talked about a lot of this in the previous tutorial, but here I want to show you how it's actually applied in a workflow. So let's go ahead and just get started. I have made this map here. It's maybe a little cafe sitting on a raised platform with a large front yard. We are going to texture this. Now, a couple notes about this video is it's going to be unlike the other videos. This is planned but not rehearsed. You'll be pretty much just watching me work, basically. And so if I stumble over my words or I say the wrong thing or I say too much, forgive me for a lot of that. The other thing that I want to note is that this is not an art tutorial. This is a technical tutorial. The art that I do will be just enough to give you an idea of how it looks and is not meant to give any tips on actual pixel art, on palette selection, that kind of stuff. You can find lots of pixel art tutorials and best practices with that in other videos by people that are much more experienced than me. So why do I keep saying pixel art though? Well, what's actually going on is that you are creating pixel art, where in a lot of games you have a high-res model with a high-res texture. In that case, it's not pixel art anymore. They're doing high-res content. In Final Fantasy Tactics, each polygon has a small, limited number of pixels that you can put on that polygon. Definitely more akin to pixel art than it is to more traditional texturing. And that's why I recommend using Sprite as your image editor for this. Sprite is tuned towards pixel art generation and editing. It has a lot of functionality specifically for pixel art. You can use Photoshop, you can use GIMP, you can use anything that you want. I recommend Sprite because of how powerful it is. Now, I keep recommending it. I don't get any kickbacks from Sprite. I'm not invested with that company at all. They're not sponsored. It's just what I found to be the best use of for me, and I believe it would be the best for you too. With all of that out of the way, I've spent 2.5 minutes talking about all of that. Let's actually get into working. So if we click on one of our polygons and we click on the texture tab, we will see we have a default texture here. Now I made this texture and imported it before this tutorial and then deleted all of the files so that you can see the whole workflow process. If you start with another map, say you're starting with a map that exists and you're editing that map, a lot of this will make sense to you. This is the texture image that comes with the blank template file that I've posted on the Discord. So that's what we'll be using here. If you click through these texture pages, you'll see that we have 4 texture pages like we talked about, and the last 3 are pretty much blank. What we're going to do for this process is we're going to lay out our UVs, and then we are going to draw some pixels in, and we're going to apply palettes to them. That's our general workflow here. So let's go ahead and get started. I've got one thing that I do want to talk about, and we'll look at that first by just exporting our texture. So I hit export texture, we have it in here, and we have our default texture name, and we'll go ahead and just save it. Now we'll see it in our directory as workflow tutorial 7.png, and we will drop it into here. And this is what we see inside of Ganesha, right? One thing that you'll note is that we don't really have a palette. This is like the default palette, and it made this palette out of the colors that exist on this already. But we want more colors for our palette than 6. Every Final Fantasy Tactics palette is 16 colors, and what we're going to do is we're going to import the default palette. So the default palette is a black and white palette going from pure black to pure white in even increments, and we can actually see that if we go here and click edit palettes. Each of these palettes in this map are the default palette. We're going to export a default palette to here called default.act, and in Sprite we're going to load that default palette. There it is there. And now you can see that we have all of these colors. Now if you're familiar with, say, web development or doing image editing any other way, you know that colors are represented by a hexadecimal code. So if we click on this and you look at the very bottom down here as I highlight this palette, you'll see that it says index 1 RGB 171717 #1111111. That #111111 is our hex code. As I hover over each of these palette entries, you'll see that each of those numbers goes up by 1. So we're going from 000, 111, 222, 333, 444, and so on, all the way up to FFF. This is the palette that Final Fantasy Tactics engine expects as the default palette, and it will apply any other palette to this palette. If one of these colors is not one of these 16 predefined colors, the Tactics engine will not know what to do with that, and it won't know how to apply your palette to that pixel. I know that sounds a little bit confusing, but we'll definitely see what we're talking about as we continue. The other main important thing to know about working in images is that you want to work in indexed mode. So I'm going to select this, and you can see that we selected the associated color in the palette. I'm going to change this color in the palette. You'll see that the color in the palette changes, and we can draw it. We can change it again to say this. Okay, there we go. And it's the new color. And this red is still here, even though it's not in our palette. This is not the file. This is not the format that Tactics expects. Let's go ahead and undo all the way back to where we loaded our default palette. What we want to do is go to Sprite, Color Mode, Index. Again, Photoshop, GIMP, whatever, probably has this option. Well, definitely has this option. But you want your image in indexed color mode. So what is the difference here? The difference is that if we are in RGB color mode, each individual pixel has that color mode, that color data encoded right into that pixel. So as I click a new color and make another new color, these pixels know nothing about your palette. The palette is just a reference in this case. And this pixel right here that my mouse is hovering is encoded with this color data directly, and then same with the next pixel over, and so on. Each pixel has color data encoded directly into it. That's not what Tactics expects. Tactics expects an indexed color mode. And you'll note that now, if I change the color on this palette, that all of the pixels that match that color will update. Same with this here. If I change this, you'll see that they all update, every single one of them. And if I draw this down here and I change our color to something else, that those pixels that I drew down are colored the same. It's not like before where I drew some red, changed my palette, and then drew some blue. Now it's this hot pink, hot purple color. So what's happening is in index mode, let's go to index mode again because I undid too far. Instead of encoding color data into each pixel is encoded only with a value that directly references an index in the palette. So this pixel does not have any color data associated with it. It's only asking this palette what color data. So as I update that palette, these pixels will update because, again, these pixels are referencing this palette entry. And that's the format that Tactics expects, and that's the format that we want to do here. So one thing to know, I'll go ahead and go all the way back to where we are in color mode RGB, and we have a limited palette. I'm going to go ahead and just change some of these colors in this palette to whatever. Doesn't matter. Now if I go here and change to color mode to indexed, what's going to happen is that it's going to look at our palette, and for every pixel on our screen, it's going to find the color in the palette that closely matches, or the most closely matches, that color data for that pixel. You'll see what I mean. So I'll go color mode, indexed, and you'll see that because this color is not in our palette, when we go into index mode, it finds the color that's the closest to it and then sets it to that index. This is generally not what we want to happen. And in fact, if we go all the way back and we just reduce our color palette to this and hit color mode indexed, you'll see that The closest color to every color on the screen is this one right here. That's not what we want. So before you change it over to color mode index, you need to load in that default palette. Now if we load the default palette, now all of these colors are represented in our palette, so if we go to color mode indexed, no pixels will change, none of the colors will change, we won't lose any density. So that's our workflow here for setting up our image. And this is the same with Photoshop, with GIMP, whatever, is you need to open your image, load in the default palette that you exported from GaneshaDx, and then change your color mode over to index mode. I don't know the exact process for doing that in GIMP or Photoshop. You'll have to do some Googling and find that on your own. But for Sprite, this is that process. So our image is now set up correctly. We are in an index mode and we have our palette. We can now save it, and when we open this again, Sprite will remember that we're in index mode, so we don't have to go through that process every time. If we go ahead and close it and then load it back up, color mode indexed. Now either Photoshop or GIMP doesn't remember that, so you'll have to go through that process every time you open the image again, which is another reason that I like Sprite. One of them does. I don't remember which one. I don't really use those tools for this. So let's take a look at our Ganesha here, and we saw this this image in Sprite. Now we want to first lay out our UVs. We want to lay out our UV map. You'll notice that every single polygon that I click has the same UV map set to it, this top left corner up here. Obviously that's not good, because if we edit this and say we put some color, put an X on here, and we save it, we can go into Ganesha and we can say import texture and import the texture that we've updated. And you'll see that that X is there, and it's on every single polygon. Obviously that's not what we want. We want every polygon to have its own information. We want to be able to put a door here, maybe some windows, put some grass down here, and we can't do that if every UV is set to the same. So let's go ahead and undo this and save it. Now there's a shortcut. We can click import texture and go here and select it every time, or you can hold Control and press R and it will reload that texture from the last time you imported it. You'll have to import the texture at least once per session, and then Control R will work when we do it. Okay? Control R. Very, very fast way to do that. You'll be doing that a lot, trust me. So it's helpful to know that shortcut. So what we're going to do is we're going to go ahead and lay out our UVs. Now you'll see that I have used a checkerboard pattern for default, and the reason that we use a checkerboard pattern when laying out our UVs is because it tells us that our UV map is in the same scale as our polygon, meaning that if we click here, this UV map is 28 by 28 pixels, 8 to 36 is 28, 8 to 36 is 28, so we know that this is a 28 by 28 sized UV map, and we know that our polygon is a 28 by 28. So when we look at it dead on, each of these squares in the checkerboard map are perfectly square. They are perfectly square. However, if we look here, this is 24 units high and 28 wide. So instead of being 28 by 28, it's 24 high and 28, and so because this ratio is not the same, these squares look kind of smushed down, and that effect is even more exaggerated here where the polygon is even shorter. It's fitting the same number of pixels into a smaller amount of space, and so they'll be smushed down. So one of our goals with our UV map is that we want these checkerboard patterns to be perfectly square across the entire map. One thing that I like to do is, now these individual cells in the checkerboard are 8 by 8, I believe. 1, 2, 3, 4, 5, 6, 7. Okay, they're 7 by 7. I like to do it a little bit smaller. So we're going to go to our second texture page, like we talked about in our first video, and I'm going to just grab this and I'm going to make a 4 by 4 texture grid, or a 4x4 checkerboard grid. And we will take this and we will just continue duplicating it over until we fill up this whole space. So we finished this. We have created a huge checkerboard image here. And this is going to be nice because as we lay out our UVs, we'll be able to tell exactly how big our stuff is. So let's go ahead and save this and let's re-import it. And now if we go up one, you'll see that we are now using our new checkerboard pattern that has smaller checkers on it. So what we want to do then is lay out all of our UVs. And we want to think about how our UVs lay out. The idea that you want to have is that similar UVs should be together. What I mean by that is all of these raised platforms, I'm going to put all of this, not this, all of these things close to each other in the UV map because we can texture all of this together at once. We'll put all the ground together in one UV map. We'll probably put the roof and the entire facade. And the reason that a lot of times 3D modelers will call this unwrapping is because you're taking a 3D object and flattening it out. So you'll see some of that process with the side of this building. So let's go ahead and just get started with that. So first of all, I'm going to select this top left polygon here, and I'm going to just make it our second texture page here. And what I can do is I can hit copy and click another polygon and paste, and it will copy all of its properties, its texture page, its palette, its UVs. All of this information will be copied directly over to the next polygon. Then we just move our UV palette down. So now we have this too. So if I go into here, just as a demonstration, and I grab this, maybe another color, maybe a color that actually contrasts against our checkerboard. So I will do this, okay? And we'll save, and we'll reload it. Now you'll see that our UVs line up like this. Two things to note is that this does not quite look like it goes through. That is because our UVs start with the red in the top left corner, but our images or our polygons have red down in this corner. So this red side is matching these red pixels, but that's not quite what we want. So when laying out the UVs, one thing that you want to do is make sure that our orientation of our vertices matches the orientation of the map, and usually you want the red ones to be top. So if you hold Alt and click on any of these widget buttons, it will rotate the pixels. It'll basically just reorder the pixels. So we'll do that to there. And now you can see that that scribble that we drew continues on through here. Let's go ahead and undo this scribble. So what we're going to do then is we want to hold Alt and get our red in the top left for each of these polygons. And we can do that all in one go by just selecting all of these polygons that we're going to use for this map. Okay, we've selected our entire set, and we'll switch to this and hold Alt, and it will apply that to all of them. So now all of these polygons have red in the top left corner when looking at it like this. So let's go ahead and copy this and paste it here. And you'll see that I am moving this almost by magic. What I'm doing is I'm holding Shift and pressing down. If you press left and right, the arrow keys, and your mouse has to be on the texture window. If your mouse is not on the texture window, you'll be using the arrow keys to change our camera orientation. Keep your mouse hovered over this texture window and press the arrow keys, and you'll see that we move our entire map. And if you hold Shift, it'll move it in increments equal to our ratio. So down here where it says preview options, shift plus arrow distance is equal to 28. So when I hold shift and press this, we will be moving our UV map in increments of 28. So let's go ahead and paste this here and move it down there. You'll see that we are starting to lay out our UV here. Paste this here, and we know that this goes right there. I think I might go ahead and just fast forward through this. But before I fast forward, I want to talk about one thing real quick. Let's go ahead and save this, and we're going to open up a map that comes with the game. We're going to open a vanilla map, and it doesn't matter which map. We'll just randomly choose map 48. So I want to take a look at one of these polygons here. We're going to click on this, and we know that this is a 28 by 28 size polygon right here. If we look at our texture, however, and zoom over to our UV map for it, and we do our math on this, if we take 107 minus 88, we'll see that it is 19 wide, and 187 minus 168, it's 19 tall. What they've done is that they have created a ratio of how many pixels per unit they want to use. So we know that this is 28 units wide for the polygon, and we know that it is 19 units wide for the UV. And so they use this ratio, 19 divided by 28. They're using a ratio of 0.678. And we can see that anywhere on this map. If we find a polygon that is not exactly square, we'll find that. I don't think there are any on this map. But if you were to make your own polygon, if we were going to bring this out to here and then shorten it like this, say we're making steps, we'll go ahead and make a little staircase just to show what I mean. And that looks like it's lined up. So say we're making a staircase like this. We look at our polygon and we see that on the z-axis we are taking 140 minus 127. Oops, 140 minus 127. That this is 13 units wide, and so we'll times this by 0.687, and we know that we need to have about 9 pixels on our UV map for the density to be the same. So let's go ahead and open this up and move this down here, and we know this has to be 9. So if we take the V value for our smaller value on here, the 188, and add 9 to it, we'll know that it has to go to 197. So instead of 207, we'll set this to 197. And by using the same ratio, we can see that our pixels are the same size between these two polygons. What's important about this is that you want your pixel density to be congruent through your entire scene. If you have disharmonious pixel density, it will become immediately noticeable, maybe not consciously, but definitely subconsciously. Your brain will be able to tell, and more importantly, your audience's brain will be able to tell that your pixel density is off. So what I mean by that is, let's go here and let's just make this a smaller region for this UV map, for this polygon. So we will just make it a little bit smaller there. Now, immediately looking at this, you can tell that this just doesn't look right. It's because these pixels are much bigger than the pixels on the polygon surrounding it. You want the same pixel density across the board, and you figure out that pixel density by dividing how many pixels your UV map is by how many units your polygon is. And generally, the idea behind this is that you are defining your pixels per unit density, and you want that to be consistent across your entire map. We've played games in the past where the character's pixel density is maybe smaller or larger than the environment, and it just clashes. It looks amateur, right? Let's be frank about that. It looks amateur, and it looks generally bad. So you want to make sure that you have that pixel density congruent. Now, one thing that's interesting to note about Final Fantasy Tactics is that if we look here, we know that this is 24 units high. It is 2 elevations high. Each elevation is 12, so we know that this is 24 high, and we know that this is 28 wide because it's aligned to the grid that way as well. So if we do that, we know that this is 28 wide. So we know that this is a 28 wide by 24 high polygon. However, if we look at our UV map, and remember this is a vanilla map, this is the developers of Fft Tactics did this. If we look at our map, we take 127 minus 108, 19, and we take 47 minus 28, also 19. So why are they doing this, especially after we all as artists now know that we want our pixel density to be congruent throughout our entire scene? That is because if we go up here to view, we'll see that there's this option called Fft Ortho Mode. You may have noticed that in Fft Tactics, everything kind of looks squashed down a bit. You'll see that if we toggle this on. This is what the map would look like in game. See how everything's kind of squashed down? The hotkey for toggling this is B. We'll press B, and we see that it goes kind of squashed down to perfect. So let me go ahead and just grab one of these polygons here and move it out into space. And I'm going to create a perfect box out of it. So let's go to here. Let's rotate it down on that axis like we saw in previous tutorials. And I'll go ahead and grab both of these, copy them, rotate them just like that, move them into place. And so now we have a perfect box. And it looks like a perfect box when we have our ortho mode turned off. This is all 6 sides of this, or rather 5 sides because you don't have a bottom. All of the sides are the exact same size polygon, like a dice. But when we import this into Fft Tactics, in game it will look like this. It's not a perfect box anymore, it's been squashed down. And so why does that matter? For one, while you're making your maps, you'll want to toggle between these two. It's easier, I found, to work with this Fft mode off. You can get a better idea of the physical space. But if you're trying to get an idea of what it'll look like in game, turn it on, and I suggest toggling between the two. So now, there's a ratio to this. I believe it's 2/3. What I mean is that with it on, this is exact height. If we turn Fft Ortho Mode on, this is 2/3 the height. We can sort of see that being about 2/3. Maybe it's 4/5. I'm not entirely sure, to be honest. It's one of the two. But what's happening is that this texture is being squashed up because it's fitting more pixels on here than it should. Remember, we're 28 high and it's fitting, or 24 high and it's fitting 28 worth of PPI, pixels per unit, PPU, I guess, pixels per unit into that same space. When we turn on ortho mode, it squashes it down so that the pixel density appears to be the same. What I do with my maps is not what the Tactics vanilla team did. I do not use a ratio for my polygons at all. So for my my 28 by 28 size polygons, I make, let me turn off ortho mode, I make these 28 by 28. So what I have is 1 pixel per 1 unit pixel density across my entire map. And we can look at a map that I've created previously. If you're familiar with Final Fantasy Tactics Battlegrounds, you'll probably recognize this. When I go into the texture for this, let's choose, say, this rug bit. This rug, we know, is, this polygon is 28 by 28, and if we look at our texture, I have done 153 minus 125, 28, 37 minus 9 by 28. I want my textures to be 28 by 28. You'll see that I have more density inside of all of these. However, they're all actually equal. Every single polygon has a 1-to-1 ratio between its texture size and its polygon size. If we look at the walls, though, I did not do that thing where this matters to me. So when you look at this, these these textures might look a little bit squashed down to you. And I'm actually okay with that from an artistic perspective. This is entirely up to you how you want to do this. You may want to do it like the original developers did, and make sure that all of these are 19 by 19, that you fit that 0.678 or whatever that ratio is as your consistent pixels per inch. You may choose to do that, or you may choose to do what I did, which is 1 to 1. One of the advantages that I have is that I don't have to do any math. When I look at a polygon like this and I see that this is X units high and X units wide, I know that I don't have to do any math. I know that this has to be exactly that many pixels high and that many pixels wide. And when you get into some more finer detail, this doesn't really have any examples of it on this map, but when you get into finer detail, you'll definitely be running into a situation where you're going to punch in, say your polygon is going to be 26 units wide, and then you'll have to apply that ratio and then multiply that in. Or if you have 1 to 1, then you don't have to apply any of that math at all. So this is entirely your choice. This is your artistic project. You do it how you want to do it. Just the one rule that I think you should stick to is keep your pixel density the same across your map. Now the other thing that I wanted to look at with this is that each of these UV maps has like a border around it. There's no UV map filling or using these pixels between these two. And if you look at these two, you'll see that there's a gap there. I don't worry about this gap. I'm not sure why they did this gap in vanilla. And if we close up this gap by taking the 4 polygons that surround it, you'll see that it looks fine. It looks actually maybe even a little bit better. And this red vertex here shares this red vertex, so why do these UV maps not share that same vertex? I don't understand. There is one element to this that you do need to know about, though, which is that you do need a border at times. And that is because of something called pixel bleed. Or texture bleed. What's going to happen when you have this polygon in your game is that from certain perspectives or certain elevations or even certain panning positions, it will sometimes grab the pixels from outside of your UV map and put them inside of the polygon. So this dark green pixel right here that we see, sometimes, let's turn this off so you can see what I'm doing. Sometimes you will see that, let's see, it's on this edge. Sometimes you'll see over here this pixel will be dragged into this UV, and generally that's not a problem, but sometimes it is a problem. So say over here, you don't want to drag in these dark green pixels onto your UV map, or these blue pixels with this palette. You don't want these blue pixels to be dragged into your UV map, because what you'll see is some very small blue pixels sneaking in right along this edge, and it'll be very distracting. You'll see where the edge of the polygon is, and it's not great. Later in this video, we'll show an example of that happening. But what you generally want to do is make sure that there's a border of similarly colored pixels all the way around your UV. So let's go ahead and go and take a look back at our other map. Okay, so we have UV laid out all of this, and if we were to go in here and just sort of grab this and just save this, reload it, we'll see that we have a consistent image. Although this one, yeah, this is right. See, it goes down. Okay, so we can see that we've drawn through and our pixels all match and it maps directly to this. So let's go ahead and undo that. I like to do that every now and then just to make sure we're fine. Now you'll see that we have another side of here that we have not mapped yet, and all of this is mapped. And if we were to map all of this in the same way, for one, we would take up a lot of our texture space, And for 2, I mean, a lot of this is probably going to be pretty similar. So what I'm going to go ahead and do is I'm going to select all of these polygons here, and I'm going to go ahead and delete them. Now I'm going to grab all of these, and I'm going to move them over here, change to my rotation widget, and rotate, mirror them, holding shift, like we talked about in the polygons tutorial. Now we'll see that these are mirror images of each other, and they are taking up the same texture space. And if I go back here and I draw my squiggly lines and save it, see that they mirror exactly. And this is okay for this. You want to be creative when laying out your UV maps. We don't have infinite space. Granted, for this scene, we probably have enough space to do this entire thing by itself. But I want to show you some tips in this, right? So let's go ahead and fill in the middle bit. Okay, so these mirror over. If we were to draw this as grass and have little tufts of grass and stuff, it would be all right if it was mirrored over here, and we're saving some space. Same with the building. We may mirror it right along the middle so that these match this. Or we may not. We'll see. We'll see that I'm also running out of space down here for these pixels. So this is one of the disadvantages to what I was saying earlier about using 28 pixels per polygon. You do run out of space a lot faster than if each of these were 19 or 20 wide. But we're going to go ahead and stick with this. So let's go ahead and undo this, and save it. And now for these ones down here, since we don't really have the space for it, I'm going to go ahead and just put them up here instead. So let's go ahead and grab this, copy it, paste it here, and then we will just move it over. Okay, we have saved this, and we now have our map. So let me go ahead and show you some of the problems that we might have. First of all, I'm going to go ahead and save this. In another tutorial, I'll show you how to deal with this, but I write batch files for each of my maps that will automatically inject them into an ISO for me. So all I have to do is double click, make tut.bat, copies it over. Now when I open up PSXE, load our ISO, we'll be able to see our map in game. Now this is going to be a bit of a mess to look at because of all the checkerboard stuff. F4 will fast forward, and what I have done is I have a save state that is after loading and is at this phase here. So if I press F3, so I save stated it here, so every time that I want to check my map, I just press F3 and we'll get to this point right before we loaded. We'll say yes, hit start, and yes, and then we can look at our map. This whole process I'll talk about in another video about quickly testing and everything, but that's what you'll see is that exact thing. So let's talk about a couple things that happened here. We have all of our textures. Now it's not doing it like I thought it would, luckily, but actually we'll see a little bit of it up here. Okay, it's a little bit hard to see maybe on the video here, especially if you're on mobile, but you'll see that between let's go ahead and screenshot this and I'll be able to zoom in on it. So I'm just going to open up Paint because it's a very fast tool for using sort of a visual notepad. But we'll zoom in, and when we look at these tiles on the roof, we see all of these little pixels that are not at all intended between this gap, and it just doesn't look right, does it? In fact, I'll bet that if we do it down here, yeah, you can see it a little bit, but it's, the checkerboard pattern is obscuring it a bit, but we do not want that, right? So this is what I call texture bleed. You can see these pixels. What's happening is that it's pulling in, let's click up here, it's pulling in this pixel color. See this lighter color here is pulling this in and smushing it into the space. See that color there? these polygons are overreaching with their UVs and pulling in the pixels surrounding the UVs, which is why we want a little bit of a gap, which is, if we go here, this would fix it immediately. So let's go ahead and do this. I'm going to just highlight this, paste it one up, grab this, paste it one over, grab this and paste it one down, and paste this and move it one over. I'll save it. I'll go into GDX. I'll reload. Now you can see that we have this sort of buffer around our UV map. We're going to go ahead and close out. Whoops, I missed. We're going to close out our emulator. I'm going to close this. I am going to create my code again to load that in. Run our ISO. Yeah, I know. This is a process. You know, nobody said it would be easy. So now we start up our map, and now when we load this in and we look at our roof, we're not going to see that same kind of bleed going on. Okay, now when we look at this, we can see that those crazy pixels are not there anymore, and we can zoom in on this, and it's exactly like we want it to look because we added that buffer. So let's go back to what we're doing. We added the buffer here, and when we go down here and look at our textures here, our UV maps are butted right up against this border. Every texture has this 8x8 pixel border. I don't know why. That's just a convention that Tactics development team did. I don't know why. But they do it, and we're going to stick to that convention because they probably did it for a reason. So we're going to grab all of our UVs here. And now see, this is taking a little bit of time. Remember how we could click this and press plus and we'll expand our selection by things that are touching it? Well, if you do the same in the UV editor, as long as your mouse is hovered over the texture window, you press plus and it'll keep grabbing every polygon that shares a space in its UV map also. So we're going to hold control and click that and just do that. Now what we're going to do is we're going to just move this whole selection down one and to the right one. So we get a border here so that these pixels match. Okay, and that's going to save us some headache down the road. You'll also notice that I put a 2 pixel border between these two, and that is so that this pixel here can match these pixels on the right side of the UV, and these pixels can match these pixels on either side of this UV. So, pretty nice, right? Before we get too much farther, I want to talk about palettes. So, we'll see that our palettes are all this default palette, all 16 of them. What if we want these to be a different color? Let's go ahead and change our palette here. Let's grab this one here, which is this, and change it to a greenish color to kind of represent grass. And then we'll grab this one here and change it to a slightly darker greenish color. Okay. And if we save this and reload it here, we get those colors, but it's a little bit weird. If we go and we save this map and we load it into our engine, it probably won't look like that. It might add a coincidence, but probably not. So let's take a look. I would be surprised if it does, but also since I'm doing a live tutorial basically, I wouldn't be surprised if it doesn't. Okay, yeah, look at this. This is not what it's supposed to look like. This is not right at all, right? That is because this texture is not using any of those 16 colors in our default palette. Whenever we save our image, we must use our default palette. We must, okay? So let's go ahead and go back here. But what if we do want to use this palette? We adjusted this palette in our image editor. So you can go down here, save palette. We're going to call it palette 1. Now in Sprite, if you hit save right like this, it will save it as an Sprite file format, and GaneshaDx doesn't know what to do with that file format. It must be a .act, and you must type it in manually. So we're typing pallet.act manually. Okay, make sure that that's the case. So we'll hit OK, and let's go ahead and load up our default palette and save to make sure that that's the case. And we'll go in here and we'll change palette number 1 to pallet1.act. Okay, nothing changed yet, and that's because we have to go and select all of our polygons. Again, we'll just do this the quick way, like this. Tapping that plus key, we'll go to our texture. We'll expand this out. I must have contracted. And remember, we have our palettes. We made our new palette at palette 1, and we are going to just change our palette to 1. Now we have our green ground. And let's hit save, and we'll load this back up in the game. And there we go. Look at that. We have green textures for our ground. Pretty nice, right? That's what we're looking for. You'll see there's a bit of a hard line there, and that's because our UV maps are not touching each other. We'll discuss that later. So let's get back to work. One thing that will be nice is that we kind of give everything a general color before we get too far into this. So let's go ahead and unwrap our house here. For our house, we are going to use texture page 2 since we don't have anything here. We're also going to go in here and select all of these pixels and paste it down into here. Make sure it lines up along the bottom. Okay. And we'll save that, and we'll reload. Now we get our little checkerboard pattern here. So now we know that this polygon is 24 units high and 28 wide, so our texture is going to match that, or our UV map is going to match that. First, we also want to make sure that our red is in the top left corner. So what is 8 plus 24? Let's open up our calculator so we don't have to think too hard about it. It's 32. So we will just double click these and change these to 32. Whoops, not that one. This stays 36. And this is going to be, oh wait. Our U stays 28 units wide, but our V will be only 24 units up and down. So this will be our 32, and this will be the 32. And now we see that we have a nice square image there. And we will copy it, put it over here, and rotate this face. Now I don't want to have to rotate the face for every single one of them. You'll see that our red polygon is in the upward direction. That's what we want. Whereas here, it's up here when we're looking at it from down. Here it's in the top left when we're looking at it from the side. So it depends on how your polygon is oriented and how the face is oriented, but that's how you want it. Okay, so our red's in the top left. Not yet. Not yet. Not yet. Now that should be it, right? Nope. Since these vertices are in the same spot, sometimes there's sort of a rendering fight distance. We're going to look at this vertice right here because nothing is overlapping that. That's the one that we want to be red. So there we go. Now if we click across these are all red top left. Perfect. So we have these. We're going to move these. We're just going to move them way down into the middle somewhere because these are not the top, right? So we're going to grab this, copy and paste it onto here, and move it up one, and move it into place so that they overlap. Now these are not matching, and we know why by now. I won't belabor that point. So 122 minus 12 will be 110. And there we go. Now they're perfect. Okay, so I've done that, and you can see that we have some polygons over here that won't quite fit our map. which is a little bit annoying. But you know what I'm going to do to remedy that is I'm going to just delete all this. And while I was doing this mapping, I was considering, you know what, I do want the face to have, the front to have its own, unique data across the whole face. If this is mirrored, it'd probably look a little too obvious. But if we mirror just these outside walls, and they'll look probably the same, the player will never see those two walls at the same time. So it's okay that these will share the same UV map. However, for the front, we probably want all of this to be unique. Let's take a look down here now. So I'm thinking making this a wooden image, like a wooden deck around this. And we're going to start by just putting this on the same palette as our house. And let's just make a new space. You'll see also that I moved my polygon or my UV map up to the corner. You want to really pack these in too. You want to not waste any textures. Okay, so this is going to use the same convention as our ground, so we want red in the top left. Okay, you'll also see that this layout matches the shape of this. That's going to be real useful later. Okay, so I'll do the same for the roof and fast forward that also. Okay, so we have a little bit of an issue, which is that these polygons are triangles. We are going to do a little bit here. We can copy the UV for a quad and paste it onto a triangle, but it kind of doesn't know exactly what to do. It doesn't know exactly which pixels to use. So we're going to physically move this around. We know that this blue vertice matches this yellow vertice, and this green one matches this red one. So, well, we're going to go ahead and rotate all of these polygons. Did we do that yet? No. So we're going to mirror these, so we're not going to worry about rotating those. Okay, so the red is in the top. This blue has to be matched over here, right? So that matches that same vertice. And then we want to drag our green one down over to here. There we go. We're also going to just copy this and paste it around to here and adjust all of this. And there we go. Now our texture is uniform. Okay, now you pretty much got the point of UV mapping, and so I'm going to go ahead and just UV map the rest of this. One thing that I will do is I'm going to, because I know that this I want to be grass and then this surface to be like a stone texture, I'm going to go ahead and put these polygons right in this space between, right here. Even though it's a different elevation, I'm just not that worried about that aspect of it. Okay, now the rest of this I'm going to fast forward. You get the point, right? So watch me do this super fast. Alright, all done with that. So not only did I set up all these UV maps, I have also set palettes, just using the palette editor in here, to kind of block out the different elements. We have some wood for the wood, or for some brown for the wood paneling. We have some brown for the dirt aspects. We have some green for the grass, and we have some blue for the roof. And I left this kind of as the white because a lot of front, building faces are kind of that stucco kind of color. So let's talk about two things. One, I could go into drawing your own pixel art and doing all that. Like I said, this isn't a pixel tutorial video. This is a workflow video. So what I'm going to do instead is I'm going to do a Google search for some grass texture. And let's type in pixel to add to this. We're just going to pick pretty much anything. I am aware that maybe we're getting into copyright territory, but let's go ahead and just grab this pixel style. Or maybe this one? Which one would look better from a top down? We can grab this. That's not so bad looking. In fact, let's go ahead and try and grab this. So copy image, and I'm going to open a new file here, and we've pasted this in. I'm also going to crop out this watermark, not because I'm trying to take credit from the original creator, but I don't want that to show up in our palette. So I'm going to just grab this, and I'm going to say edit and crop. Where is crop in this? I think I have to go to, oh, there it is, under sprite. So we hit crop. Now check this out. If we go here to where we can load our palette, we can say new palette from sprite. We click this, and it'll ask us some questions. Create a new palette with a specific number of colors or less. I'm going to say 16, because that's how many colors we want, and hit OK. And now it has created a palette from this image. Every single color in this image is represented here. And if we change this sprite to indexed, we can see that if we change like this, orange, you can see some of these little rocks in here changing. Let's change that back. And probably a better color would be to change this green. If we just hue across, you can see that we are in index mode and that our palettes are lining up. One thing that I like to do before anything is I like to go here with this drop down and sort by hue, and then sort by saturation, sort by hue again, and you'll see that our colors are flipping all around. Well, what if we want to update our palette without this happening? Because remember, these pixels are referencing an index in our palette. When we sort our palette or we move colors around in our palette, if we grab this and just move it down here, these indexes change, or the palettes for each index change, the colors for each index change in our palette. These are still just referencing an index in that palette. So let's go back to where this was, and we want to turn color mode to RGB before modifying our palette. Now you can see that our palette is changing. It's which colors are in our palette. Maybe brightness is a better one to sort first. Or you can do it manually. Let's do it manually. It seems like the auto sorting is a little goofy. So this would probably go here. And generally you want to be in control of your palette. You want to make sure that your palette colors are matching, so that when you go to pick a color, it's easier to pick that color. So we'll move this up here. Let's move this after this one. Feels like a pretty good place for it. Or you can organize it in other ways. For example, since this is kind of between green and pink, you can do sort of like a cross or whatever, but work only within the first 16 slots of this palette. So now we have this new image, and if we copy this image and paste it right into here, look, it's adapting to the palette that we have. That's not what we want. So let's go here and say save palette. We're going to save this palette as palette2.act. And then here we are going to load that palette, palette 2, and you'll see all these colors have changed. And now when we grab this, copy it, and paste it into here, we have the actual colors of the image. We're going to make it a little bit smaller. This is, again, not an artistic tutorial. Well, first, before we paste our grass in, because we know that we want this to be grass, right? First of all, we know that this is on texture page 1, and this is our UV for it. So you'd see 0, 1, and you have to kind of imagine the UV, right? Well, not necessarily. If we go here, we have an option that says export UV map. So we'll export the UV map. It will give us a default username or a file name. We'll go back here and we'll see that the new file is in our directory. We'll go ahead and open it. And we have the same size image as our texture image, except it has outlines for all the UVs. So let's go ahead and Control A to select all, Control C to copy it. I've already created a new layer here. You can just right click on this and say new layer, and you want to do this on a new layer. And you can see that we've pasted down our the outlines of our UV map. So let's go back to our base layer, and we know that this is all of our grass. So let's go ahead and just copy a big chunk of this, and we'll paste it in, and we'll resize it so that it'll fit in here. It won't look, oops, I missed the little handle there. So it won't look fantastic, right? It doesn't look fantastic, but it's okay. It's okay. So we have just plopped a big chunk of grass onto our map. Let's turn this off. And now if I save this, remember we talked about Tactics wants these maps to be black and white. So load up your default palette, save it, and then I usually just do a Control Z here and undo that. Now if we load this in, well, that looks pretty messy, right? Did we not save it? We did save it. We saved it right. Oh, you know what happened is when we pasted in our pasted this in, for some reason it overwrote with, I don't know why I did that. That's weird. Maybe I pressed some hotkey that I didn't mean to press. It's okay. Let's paste this right in here. In fact, let's actually paste this into a new layer. And I'll show you why in a second. So we're going to paste into the new layer. If we shrink it down, we're going to lose a lot of that detail, right? So let's just go here. And then all I'm going to do is go down to this layer, choose my magic wand, and select this border. And then go back up to the second layer with that selection still, and press delete, and it'll delete everything that is in that grass. And then we can just go to these other pages and delete that too. Now let's leave this on its own layer. Okay, and we'll save it as default, save it, and load it in. Okay, that's better. Of course, this does not look like what we want it to be, and that's because this texture palette 1, let's go to our edit palettes, and we have palette 2 here, which we should probably rename these in a minute, but I load in that palette, which is exactly these colors that we saw right in here. We load these colors in, and now we have that. Sure, it looks janky. That's because, you know, like I said, we are not being artistic here. I think I've said that a few times. But we're going to do the same for all of these. Or rather, we would do the same for all of these. I think I've made the point with this. We're not going to really worry about this. I'll show you something with the fences. This part is not the color that we want it to be, and that's because if we turn on our UV maps, we can see that all of this is grass with the exception of this. This is not supposed to be grass. So let's go ahead and just add another color here. Let's make this kind of a brownish color. Find a brown. Okay, and we will increase the brush size, and we'll just kind of draw right on top of that. And then let's copy this, paste it over here, and make it a little bit lighter. Just a little bit lighter, make this smaller, and we can just add some sort of, you know, some rocky type shapes, you know, for detail. You know, it doesn't really matter. You would probably want it to matter when you're making your own thing. But let's turn that off. And first thing is we're going to save our palette. Yes. We're going to load our default palette, save the file, undo to go back to this, reload, and that's still not what we want, so we have to re-import the palette that we just saved. Why? Oh, these are not the same. This is not the same palette, so these have to be palette 1. And you can see that, yeah, it doesn't look great, but this is the general idea that we're going for. Just like that. Now we can, you know, because these two are the same palette, what's kind of nice is that we can go in and we can grab, you know, we can turn our UV map back on. We can grab some of these pixels here that make up that edge and put them right above here, and then just sort of grab this and let's make it smaller and do a little bit of this. Kind of actually make it look like the grass is coming down off the thing. It's a little embarrassing doing such sloppy pixel work, but I'm sure that you'll understand. So we'll save, reload, and now we can kind of see that it looks like this is coming over. And even as an art tip, even though I said that this is not an art stream, I recommend doing something like this, grabbing this color and grabbing a darker value of it and just kind of putting a darker version of it underneath all of these. Okay, and whoops, I missed a little bit. I guess this is fine. So let's go ahead and just save that, come back, and because we just added this to our palette, we need to save it to our palette, say yes, and then we import it back in. There we go. Now it kind of has a bit of a 3D edge, 3D appearance to it. Even though we know it's not 3D, we know that this is all one flat surface here. Kind of makes it look a little bit more 3D. It looks like this grass is actually hanging over that dirt part. And you'll notice too that even though these are using the same part of the texture and they mirror, you can't really tell that much. Like you can tell here, obviously, because this is such a standout like graphical element, which you'll want to avoid in that situation or plan around it. But you can see that just mirroring these really hasn't had a negative effect on it. We can do the same with the shingles. We can do the same with this. Let's take a real quick look at this fence. So this is on our third page, which is all the way down here. Let's turn our UV back on. So in a sprite, this is typically completely transparent. As I paint this, you'll see that we see that the transparent background. So what if we do want that in our thing? So let's go ahead and make all of this transparent. Let's get rid of all these checkerboard template here. And we want to build a fence on here. So we're going to go ahead and use the same palette for the sake of ease. I think that you understand by now how palettes work. Okay, so now we have this fence. Let's save like that and paste it in, and we see that we have our fence. We want to use texture palette 1 for these. And we will go down to... Okay, so we've got our fence here. You can see that I've only got 3 of these for all of the fences. It looks like we didn't quite go over far enough for this, so let's go ahead and fix that real quick because it's going to bother me if I don't. And default palette, save. There we go. So we have a pretty convincing fence here. We can probably flip this horizontally, flip the UV on this horizontally. Same with this one, so that the posts are, you know, on the edges, which is nice. And let's do that here too. Yeah, not so bad, right? Let's go ahead and just so that we don't have to do that same math stuff over there. Now, the reason I wanted to show you this fence is because they have transparency in these pixels. And transparency is a bit of a thing you have to know about. So if I pull these out, you can see behind this fence, you can see the polygons behind it. You can have your pixels be either transparent entirely or opaque entirely. You can't have semi-transparency. So if you're trying to create like a window with kind of a blue tint to it, you can't do that in the Tactics engine. It will either be completely see-through or not see-through at all. So let's go ahead and save this. And the way that this works is if we look at our palette, we'll see that each entry in our palette has an alpha value. An alpha value, it will only be completely transparent if your alpha is 0 and your RGB are all 0. So as soon as I change this R up a little bit, you'll see that we're no longer transparent. Even though our alpha property here is 0, these are now fully transparent. In fact, and if we change our alpha to 255 and we turn RGB to 0, then it's black and we can't see through it. The only way to get transparency in Final Fantasy Tactics is if your R, G, B, and A are all 0. That's the only way. One thing to note is that when importing and exporting your palettes, that alpha channel does not come along with the export. You'll have to do that on your own in the image editor that you're using. No matter what you do, you can't import or export alpha value. So even though we have this alpha value here, if this for whatever reason was not alpha, there's a setting somewhere in Sprite that says whether or not the first cell is alpha or not. If this was not the case, if this was not transparent, these would all appear as black, but when you go to import it in here, if this is still alpha 0 in here, then it won't be transparent. Kind of belabor that point, but the point is that you set alpha in Sprite, you set alpha in GDX, and it doesn't transfer over no matter how much you import and export those palettes. That's why I wanted to show you this fence. And really with that, I think I've shown you everything that you need to really know about with your texture workflow. We've talked about the different palettes, and of course you can import this palette to any slot, any palette to any slot. You can modify this palette as much as you want. You can grab images from out of here, and using that technique I showed you to generate a palette from that image, you can make your own palettes and import them into here. And really, that's everything. That's everything. You now know how to work with your files, you know how to work with your palettes, you know how to lay out your UVs, you have some best practices with UVs. Hopefully nothing's stopping you now. Go ahead, if this tutorial was not comprehensive enough, this is kind of an experimental tutorial for me. I didn't plan any of this, I just kind of worked and let you watch me work while I talked about what I was doing. If I left out important things, or if it's too confusing, or if it's too over-explanatory, let me know any of that. I'm in the Tactics Discord. Description will contain the links to that Discord. You can message me privately or directly. My username on there is Carmichael. Or you can just ask the map editing channel too for any of that. So thank you for listening to this very long, very experimental video on texture work. We'll see you in the next one.